So moving on to question number 12 now. What do we observe in the determinant? Again, all the terms are same and their placement is different. So that they are differently placed. So now what are the points that we have to keep in mind? First thing, can we take anything common from any row, any column? No, over here not possible. Can we add up all the elements to get a particular term? Now let's see, if I add up along all the elements along rows or columns, I'll get exactly the same term. So again, it's my choice. Now what I'll do is, I'll just write C1, C2, C3. So over here, what I'll do is, I'll add all the elements along column 1. So it will be like this. So what do we observe? In this particular question, I can add along row or column, I'll get the same result. The other elements, I'll write as it is. So let's see, what do we get? The same term, x square plus x plus 1. So all the terms of first column are same. So what I'll do is, I'll take it common from column 1. So we will take this particular term common from column 1. So it will be x square plus x plus 1. So it will be 1, 1, 1, x square 1, x square 1. So since we have 3 ones along column 1, so what I'll do is, I'll try to make 2 zeros. So again, we'll fix this thing. So we will write C2 such that C2 minus C1 and C3 such that C3 minus C1. C1 I'll fix and subtract it from both the terms. So it will be x square plus x plus 1. This first row elements will be same. Now for the second, what we will write? 1 minus 1, 0. 1 minus x will be 1 minus x. X minus x square will be like this. 1 minus 1 will be 0. X square minus x and 1 minus x square over here. Now again, what do we observe? Before expanding, let's try to take maximum things common. Over here, what do I observe? That this is 1 minus x and this is x minus x square. So can I take anything common from x minus x square? Yes, of course, I can take common. So, and from here also, what do I observe? This is x square minus x and this is 1 minus x square. So now what I will do for this particular element, I can write, since it is 1 minus x common, so if I take x common, I will get 1 minus x. And over here, for this particular element, I will write x common, so it will be x minus 1. And this element can be written as 1 minus x and 1 plus x, applying the identity a square minus b square. So now let's proceed further. So what do you observe from this particular column? Can I take 1 minus x common because it is present in both the terms? Similarly, from this again I can take 1 minus x common. So now let's take 1 minus x common. So if I take 1 minus x common, let's see what do we get. If I take 1 minus x common, I'll write whatever I have written here. 1 minus x common from R2 as well as from R3. So I'll have 1 minus x whole square. So then I'll have 1 minus x whole square. Then what will I do? I'll write the remaining elements. So first row will be same. For the second, this is 0, this is 1 and this is x over here. For this it is 0. Since we have taken 1 minus x common, it will be minus x that will be left and this will be 1 plus x. So now we can expand. So now if I expand, it will be 1 plus x square plus x, 1 minus x whole square. Expanding along column 1, so this will be 1 plus x square. So now what do I have? I have 1 plus x square 2 times and 1 minus x whole square. So this can be written as 1 plus x square into 1 minus x whole square together. And if you can recall, this is formula 1 minus x cube. What is the formula? Formula is a cube minus b cube is equal to a minus b, a square plus b square plus ab. So this formula we have applied. The reverse of this formula, it is present over there. The whole square will be as it is. Hence the result. There is one more method of doing this particular question. Let's see. Again, this is our standard method. Now, if with passing times, when you will be solving many questions based on this, there will be certain things which will directly come to your mind. Like over here in this particular question, what is the another method of solving this particular question? I can apply an operation like R3 such that R3 minus X times R1, and I'll be able to obtain answer in 2 steps. So let's see. So I'll write my R1 as it is and R2 as it is, because no changes in R1 and R2. Now for R3, what I'll do, X, in place of R3 I'll write X minus X times of this, so this will be 0. Then for this, X square minus X time of X, so again it will be 0. Then for this, it will be 1 minus X cube. Now just see here, we are in just one step, we are getting 2 zeros. So now I can directly expand and get my answer. Let's see. So what we will do is, I'll expand it along R3. So if I expand it along R3, sign notation is plus minus plus. So it will be 1 minus X cube. I'll write 1 into 1 minus X square into X. So it will be X cube. So what is the answer that we are getting? It is 1 minus X cube whole square. See. So not necessarily this is a 4 marks question, but it is not necessary that you have to do 4-5 steps. In just one step also, if you arrive at an answer, you will be getting full marks, because the operation that you have applied is valid, and for a 4 marker question you have to apply at least one operation. So perfectly fine. So any of the 2 methods you can apply over here. Okay, so question number 13 now. What do we have? We have an expression over here. So what do we observe? There are certain things which we observe in this particular question. What are those things that we observe? It is minus 2b over here. So what do we observe? That this is 2ab. Whatever term I want, 1 plus a square plus b square, all the terms are there but with different signs. So what is the main thing is, I want this term either in column 1, column 2 or column 3, so that I can take it common. So I'll be working on that particular thing. So now what I plan to do is, I'll write this particular C2 as C2 plus A times C3. Now what will be the result? 2AB, if I multiply this by A and add to it, I'll get 1 0 over here. In that process, something will happen to this and something will happen to this. So one operation is taken care of. Now over here, what do I observe? This is for this particular thing because of the difference in sign. Now the same terms are over here, 2AB and 2A. So if I multiply this by B and subtract it from here, definitely I'll get 0 here and something will happen to this particular thing. Let's see what happens. So what is the operation? This is C1 such that C1 minus B times C3. C1 minus B times C3. So first of all, we'll do everything for C1. C3 is unaffected, so we'll write C3 as it is. So let's proceed. So I'll write 1 plus A square minus B square minus B times C3. So minus B times C3 means minus 2B. This is 2AB minus 2AB will be 0. This is 2B minus B times 1 minus A square minus B square. Similarly, this is 2AB. This is for C1. So completed the operation for C1. Let's move on to C2. C2 says this plus this. So this will be 0. This will be 1 minus A square plus B square plus A times of 2A. This will be minus 2A plus A times of 1 minus A square minus B square. And the last term will be minus 2B, 2A, 1 minus A square minus B square. Okay, fine. So now let's do the calculations. So what calculation will I get over here? Let's see. Let's do the calculation and then we will write it in form of determinants. So for this, the calculation is, if I write, this is 1 plus A square minus B square, minus into minus plus 2B square. So what will I get? Minus B square plus 2B square. So I will get 1 plus A square plus B square. So I am getting whatever I wanted. Similarly, let us do the calculation for this particular thing. So what will I get? 2B minus B times, So I'll open up the bracket along with the negative sign. So plus ba square plus b cube. So this again will give me b plus ba square plus b cube. I'll take b common. So it will be 1 plus a square plus b square. Okay, then let's see what we are getting for this. So it is 1 minus a square plus b square plus 2a square. So minus a square plus 2a square will give me a square. So again I will get 1 plus a square plus b square. Now for this particular term, let me see what I am getting. Minus 2a plus a minus a cube minus ab square. So over here I will get minus a cube minus ab square. So I can take minus a common. It will be 1 plus a square plus b square. So we have done the calculation of all the 4 terms. Let's write it in the form of determinant. So what do we get if I write it in the form of determinant? Let's see. So I'll write it as 1 plus a square plus b square. This is 0. This is b common, 1 plus a square plus b square. Then the second column I'll write it as 0. 1 plus a square plus b square. This is minus a, 1 plus a square plus b square. This is minus 2b, 2a, 1 minus a square minus b square. So what do we observe? We are getting something common from 2 columns. This is this term, this term, this term, this term. So one from column C1, another from column C2. So I can write it as whole square of this particular expression. So let's see what we are getting. So we will write it as taking 1 plus a square b square common from C1 and C2. So what we will get, we will write it as 1 plus a square plus b square whole square, and this will be 1 0 b, this will be 0 1 minus a, this is minus 2b 2a, and 1 minus a square minus b square. So now let's see if I am getting something else, if I can do some other operation to make one more 0. So over here just try to observe what other thing that we can do, or we can expand at this particular step also. So let's see if I can apply an operation which says R3. I can make this 0 because I have 1 0 over here. So I can write R3 such that R3 minus b times R1. If I multiply this by b and subtract it from it, remember this is very important point. If for an operation you are adding for an operation you are multiplying or dividing by any constant, then you don't have to multiply or divide the determinant. If you are doing an individual operation where you are simply writing a row multiplied by a particular constant, in that case only you have to divide, not in this particular case. So I'll just write it as 1 plus a square plus b square whole square. Other terms will be 1 0 minus 2b, and this will be 0 1 2a. This will be 0 r3 minus b times, and minus a times 0 will be minus a only, and 1 minus a square. Let's see what we are getting. 1 minus a square. So I'll write it as 1 minus a square minus b square minus b times, so plus 2b square. So what will I get? I'll get 1 minus a square plus b square. So it will be 1 minus a square plus b square. So now let's expand it along column 1. So what we will get? 1 plus a square plus b square whole square. So it will be 1 minus a square plus b square plus 2a square. So what I'll get? I'll get 1 plus a square plus b square square, and this together will give me 1 plus a square plus b square. Hence the result, this is cube over here. 1 plus a square plus b square whole cube. Number 14. Now what do we observe here again? These whatever tricks and tips we are using in all the questions, not necessarily a particular question can be done by that particular method only. Just go through all these solutions and then try to think of are there any other ways or are there any other operations of doing a particular question? Once we are through with all the questions, I'll be giving you assignment where you will be able to apply whatever tricks and tips we have used over here so that your understanding skill is also developed. So now if we move on to this particular question, what do we observe over here? This is a square plus 1, b square plus 1, c square plus 1. Whatever term I want, if I add up along any row or column, I am not getting it directly. So what I will do is, I will try to think of making these terms. Now, how can I bring in squares over here? What I will do is, I will apply this operation which says R1 such that I will multiply this whole R1 by A, R2 by B and R3 by C. You must be wondering how did I come to this particular point? Now just observe, we have A over here. If I multiply it by A, I'll get 2A squares over here. Similarly, if I multiply this by B, I'll get B square over here. Similarly, if I multiply this by C, I'll get C square over here. So why did I apply this operation? Because the results demands that all the terms should be squared. So in order to make determinant square, I have to multiply. So once I multiply, remember we are doing it individually for row. So we have to divide the whole determinant to nullify the effect of multiplication. So over here, what will I get? A times A square plus 1, we'll move row wise. This will be A square B, this will be A square C. And for this it will be AB square, B times B square plus 1 and B square C. This will be C square A, C square B, C times C square plus 1. Now, what do you observe? What thing common we observe over here is we have A over here, we have B over here and we have C over here. So let's take A common from C1, B common from C2 and C common from C3. So in that way, what will I have? I'll have A, B, C common from all the three columns. So in other words, this will be cancelled. So no effect on the question. So it will be A square plus 1, B square, C square, A square, B square plus 1, C square, A square, B square, C square plus 1. So what do you observe? You are getting all the terms somehow similar to the right hand side that you have to prove. So now what operation will I apply? I can add it along row wise. So I will get all the elements of first row same. I cannot add it column wise because in that case I will get different terms. So what operation will I apply? We are shifting upwards. So I will write R1 plus R2 plus R3. So this will be 1 plus A square plus B square plus C square. Similarly, this will be 1 plus A square plus B square plus C square. Similarly, this will be 1 plus A square plus B square plus C square. And other terms will be same, B square, C square, B square plus 1, C square, B square, C square plus 1. So now, what do we observe? We can take 1 plus A square, B square, C square common from all the three elements of R1. So I will take 1 plus A square plus B square plus C square common. So what will I get? 1 B square C square, 1 B square plus 1 C square, 1 B square C square plus 1. So since we have three rows along first row, so I will fix this and try to make the other two as zeros. So what operation will I apply? I will write C2 such that C2 minus C1 and C3 such that C3 minus C1. So let's see what we get once we apply this particular operation. C1 has no effect, so it will be as it is. So whatever calculations are there, we have to do for C2. So for C2, what I will do? I'll just write the first thing as it is. So we will have 1 plus A square plus B square C square. Then I will write the first elements of C1 as it is. Then for this it will be 0. B square plus 1 minus B square will give me 1. C square minus C square will give me 0. Then 1 minus 1 will give me 0. B square minus B square will give me 0. C square plus 1 minus C square will give me 1. So here we are. So write 1 plus A square plus B square plus C square. If I expand it along this particular here, I'll get 1. So the result 1 plus A square plus B square plus C square. Number 6 in between the whole exercise till question number 14, exercise 4.2 is all. complete. Only question number 6 is left. So if you observe this type of question, this is slightly different question than the questions that we have tried so far. So for all these type of questions, this technique you will apply for all the questions. Just observe, had it been a matrix, what kind of matrix it would have been. You observe all the diagonal elements are 0 and the elements below the diagonal and above the diagonal are opposite in sign of each other. How? This is A over here, this is minus A, and this is B, this is minus B, this is C and minus C. So this is a skew symmetric matrix as we have discussed before. So this is a skew symmetric matrix. So had it been a matrix then. So now what I will do, I will say if A is a matrix, then it is skew symmetric if it is equal to if it's transpose. So this is the result we know. Now, if I find the determinant, what other result I know? Determinant of A and determinant of A transpose is same. So, applying this particular property over here, I will write determinant of both the sides. Now, in place of A transpose, what can I write from here? I can write it as minus of A. So what will I get? 2 times of determinant of A is equal to 0. So determinant of A is equal to 0. Hence the result. So in all these type of questions where you are getting these type of terms, all the diagonal elements are 0 and the upper and below diagonal elements are opposite in sign of each other, the same steps you will do for all the question. Even if it is a 4-marker question, you will be getting full marks.